The United Nations braces for stormy space weather. Presented by Science at NASA. Rewind to the late 1950s. The Soviet Union had just launched the first artificial satellite, Sputnik. The United States, caught short, was scrambling to catch up, kickstarting a Cold War space race that would last for decades. Space was up for grabs, and it seemed like anything could happen. Into this void stepped the United Nations. In 1958, the General Assembly, recognizing the common interest of mankind in furthering the peaceful use of outer space, and desiring to avoid the extension of national rivalries into this new field, established the Committee of the Peaceful Uses of Outer Space. COPUOS became a forum for development of laws and treaties governing space-related activities, setting the stage for international cooperation on problems that no one nation could handle alone. As the years went by, COPUOS membership ballooned from 18 to 74 nations, while items such as orbital debris, near-Earth asteroids, and global navigation were added to the regular agenda. At each meeting, members confer about these issues, which present some key challenge or peril to the whole planet. This year, a new item is on the agenda: space weather. This is a significant development, says Lika Guhathakurta of NASA headquarters in Washington, D.C. By adding space weather to the regular agenda of the COPUOS Science and Technology Subcommittee, the UN is recognizing solar activity as a concern on par with orbital debris and close-approaching asteroids. Space weather is the outer space equivalent of weather on Earth. Instead of wind, rain, and snow, however, space has radiation storms, solar wind, flares, and coronal mass ejections. The source of space weather is the Sun, and although solar storms are launched 93 million miles from Earth, they can make themselves felt on our planet. Strong solar storms can knock out power and disable satellites, says Guhathakurta. It's a global problem made worse by our increasing reliance on sensitive electronic technologies. The potential economic impacts of space weather are significant. For instance, modern oil and gas drilling frequently involve directional drilling to tap deep oil and gas reservoirs. This drilling technique depends on accurate positioning using GPS. Drill heads could go awry, however, if the sun interferes with GPS reception. Solar energetic particles at the magnetic poles can force the rerouting of international airline flights, resulting in delays and increased fuel consumption. Currents generated by magnetic storms can damage transformers and increase corrosion in energy pipelines. A key problem that the UN can help solve is the gaps in storm coverage around our planet. When a solar storm sweeps past Earth, waves of ionized particles ripple through Earth's upper atmosphere, and the whole planet's magnetic field begins to shake. These are global phenomena, says Guhathakurta. We need to be able to monitor them all around the world. Industrialized countries tend to have an abundance of monitoring stations. Developing countries are where the gaps are. With assistance from the UN, researchers may be able to extend sensor networks into regions where it was once politically impossible. Space weather might play a role in Earth's climate, too. For example, the Maunder minimum, a 70-year period almost devoid of sunspots in the late 17th to early 18th century, coincided with very cold winters in the Northern Hemisphere. Researchers are increasingly convinced that variations in solar activity have regional effects on climate that pay no attention to national boundaries. From now on, space weather will be a matter of regular conversation among UN diplomats and emergency planners. This is important because while space weather is no longer up for grabs, it is still true almost anything can happen. For more news about space weather and its global effects, visit science.nasa.gov.